Next one is we are going to see how we are going to use MIMO. MIMO, you know, it is multiple input, multiple output. So we are going to use MIMO system, and we are going to see how it is going to improve the performance of my system. So I'm going to use MIMO. MIMO means you know you are not using one antenna. I'm using multiple antennas for transmission and reception in order to improve my performance of the medium. So you want to get a better performance. I'm going to improve the I'm going to increase the number of antennas on the transmitter and receiver side to get better signal quality at the receiver. So these are the parameters I'm defining. You see here, transmitter power, transmitter gain, what is the range. So I'm going to transmit for 2.7 kilometers. I'm going to transmit my antenna is going to transmit the signal for 2.75 kilometers. So after 2.75 kilometers only, I will be having my receiving antenna. Okay, and all other parameters, I'm going to have 8 transmitters and 8 receivers. Okay, and I'm just running this code. Just running this code. Just running, it's fast. Just running. So we have got the output. I'll just show you the output. This is the constellation diagram we are getting. I think you can see the new window now. This is the constellation diagram we are getting. So it is a 4 cross. I am using 16 elements, and I am using a OFDM along with the gain modulation. Okay. That is why I'm getting 16 constellation elements. This is the in phase and quadrature phase, and you can see the plot is not that much scattered. It is available very near. I'll just explain the program, what we are doing here, so that you get a better understanding. First, I'm creating all the parameters. Next, I'm plotting the environment. I'm seeing what is the MIMO environment. Then I'm setting the signal transmission, all the encoding, modulating everything. Then we are transmitting, we are generating random bits, encoding, scrambling, and I'm doing QAM modulation. So how much QAM I'm doing? I'm doing 16 QAM. That's the reason why in the constellation you see 16 symbols. Then I'm doing after 16 QAM, I'm doing OFDM. OFDM I'm modulating and I'm transmitting. The transmitter I'm giving all the OFDM data. The receiver I am going to after OFDM, I am using antenna for radiating. So I am radiating all the parameters. And the signal is propagating with the channel parameters. So I am giving the fading model, everything, propagation loss along the signal. The receiver side, I am first doing, I am just receiving the signal. I am first doing OFDM demodulation. I am then equalizing. In case because of OFDM, if there is any signal rotation, I am equalizing. And then I am decoding, and then I'm measuring BER. And once I measure BER, I'm finding out the constellation diagram. This is what is done in the program. And you can see the constellation diagram is noisy. Because you know that wireless channels are not that perfect. So definitely you will have noise, the effect of noise in the channel. So you cannot ignore that noise. So you have a constellation diagram, and I'm using 16 QAM. Okay, I'm using 16. This is one thing I want to show to you.